All right, well, I would like to thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fischer-Technik division over here at Studica. And today I'm going to provide you with an overview of Fischer-Technik's line of pre-assembled industrial simulation and training models. Whether you're an educator at the high school level involved in CTE training, a college professor or industrial trainer teaching programming skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, I believe this presentation will offer some important options for you to consider. Now let's start off by considering the skills gap. Now, if you've attended any of our other Fischer-Technik education webinars, you've probably heard me discuss the importance of STEM education. STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has become perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Now, not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and who had a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions we will be looking at in this presentation, let's consider that last skill area I just mentioned, which is that of a PLC programmer. First off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. So essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. And to get a clear picture of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at the list of current job openings for PLC programmers on Nuvu for the date of February 27th, 2020. Those listings showed 15 positions at that time being advertised with salaries over $75,000, two of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as that's going on, as this workforce of tomorrow is getting their training, more and more manufacturing companies facing the urgent need right now are enrolling their incumbent workers into private training schools offering such programs. Now, how long does it take? Well, it depends on a student's background and experience, but very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed here on the screen, as well as learning how to really efficiently and effectively troubleshoot and address errors and equipment breakdowns, of course, more training would be required. So once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. There is high school CTE, career and technical education programs. There are adult continuing education programs. There's vocational training, technical training, and trade schools. and employer-sponsored incumbent worker training programs, as I just mentioned. Now, this all being said, the question that still arises for the educator, and that's whether you're an educator in the university or the vocational school classroom, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? And how do you get away from the dryness of textbooks and video presentations and instead really make it realistic and hands-on? But there are also other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. In each of these cases, and of course there are more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled, small-scale models which are designed to replicate, in both appearance and function, various automated robotic machines and systems which are commonly used in commercial manufacturing. Now, before we begin to look at each of these models, let me provide you with just a little bit of background on what fischertechnik is all about. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, based around their unique building system. Now, what makes their system unique is that unlike other popular construction systems where the components are designed to simply stack, with the fischertechnik system, it was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, many of the parts in the system are designed to slide together and lock in place, and the hundreds of different parts available will also help engineering students to address very specific design needs. The system itself was created in the 1960s by German inventor Artur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, and he was also the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, whether those intended for the retail market or those intended for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by fischertechnik for the education sector are subject-specific sets, focusing on different STEM-related areas, things such as mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. The line of fischertechnik simulation solutions, which are, of course, the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated and robotic machines and systems. Models in the Fischertechnik simulation line include conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. And besides these individual models which focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. This factory simulation model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which all work together as one self-contained material cycle. But before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using Fischertechnik solutions. Now, I will apologize in advance as the first few points are things I've already touched upon, but I think in each case it is worth repeating. First, Fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. And this can be for understanding how automated systems work, or it can be for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models once again are designed to realistically replicate, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in many cases tabletop sized, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each Fischertechnik simulation model is hand-assembled and is a high-quality German-made product. Each model is also available in 2 different versions. The first version is a 24-volt version, which is designed for use specifically with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or if you choose to use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or of course many others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language. If you like ladder diagram, sequential function charts, functional block diagram, structured text, or instruction list, whichever your choice is, you can use that to program your models. Now, please note that with the 24-volt versions, no PC is included, and all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. There will be one exception, I'll get to that later. Now, of course, this should not be an issue as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users and for educators not versed in or familiar with PLC programming, there are also 9-volt versions of each model available. These 9-volt versions ship pre-wired to Fischertechnik's own proprietary robotic controllers, which are the Robotics TXT controllers, and each controller is pre-programmed using Fischertechnik's own RoboPro graphic programming software. The only additional component required with these 9-volt versions will be the addition of 1 or more 120-volt power adapters, which will be specified with each model we discuss. Otherwise, in most cases, these should be ready to use right out of the box. If you are involved in demonstrating or exploring IoT, which is of course the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, Fischertechnik also offers a special IoT-focused version of the factory simulation I mentioned before, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. Now, in this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss this in more detail just a little bit later in the presentation. And finally, Fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price, as well as, of course, being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's begin to look at the models which are available. The first model we're going to look at is the vacuum gripper robot. Now, as you will see in just a second, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position work pieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see on the model in this video, and also a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds total. The 24-volt versions of this model, as well as the other 24-volt models we will look at, each have a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCV terminals with pushing connections for all inputs and outputs. Now again, the 24-volt version of the model, as well as all 24-volt versions, will require you to provide the PLC and the programming. The 9-volt version, which is the version you see in this video, will once again come wired to the Fischertechnik's Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will also mention that for this and all the other models we'll look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next up, we have the automated high bay warehouse. The model we're going to see features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming, and the reason for that is because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step of which will, of course, require its own very specific coding. The dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a total weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCV terminals with pushing connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. The 9-volt version is pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is of course required. The next model we are looking at is the multi-processing station with oven. This model features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a total weight of about 11 pounds. Again, it's available in both 24-volt versions for use with the PLC of your choice, or the 9-volt version, which in this case is connected to two robotics TXT controllers. So in this case, two 120-volt power adapters will be required for all operations. Just be a second or two more, we'll look at this. Very nice. The next model in our progression is the sorting line with color detection. The simulation model you're going to see here features a system for detecting work pieces of different colors and sorts them via conveyor belt into 3 different storage bins. Components on this model will include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you will need to provide the PLC and the programming. The 9-volt version, once again, comes pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is, of course, required. The next model we'll look at is the factory simulation, which combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection into one self-contained material cycle. The cycle we're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they are moved to the multi-processing station with the oven. After the workpiece has been processed by this machine, it's then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one work cycle, it has a much larger footprint. In this case, it's approximately 39 by 31 by 16 inches, and the total weight of this unit is between 43 and 46 pounds, depending, of course, on whether you're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions and the fact that this does come pre-assembled, please note that this model will only be shipped flat as freight on a pallet. Now, I'd also like to point out that as the factory simulation models tend to be in high demand, please anticipate that we sometimes will run into a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. So just allow for a little bit of time. A few other things to note. First, this is again available in both 24-volt and 9-volt versions. Now, in this case, the 9-volt version is wired to 5 robotics TXT controllers, but because of the way that they're daisy-chained, it will only require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware that might be required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both the multi-pin connectors as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations we just discussed who might need to transport the model or who just want to protect it when not in use. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, and it also has 4 steel-tilled handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches with a weight of approximately 53 pounds without the model in it. Please note, though, that even when using the travel case, these models will still need to be shipped flat. The next model we're going to look at is a basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a dimension of, or diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of the transport as you might desire. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. And as before, this is available in both 24-volt versions, 24-volt versions as seen here, and 9-volt versions connected to the robotics TXT controller is shown here. With the 9-volt version, 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except that this time it has a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. And again, it's available in both 24-volt version as shown here, and a 9-volt version wired to the robotics TXT controller, which again requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. And again, it's available in both 24-volt version for use with PLC and a 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees, Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. And as with the other models we've looked at, this is again available in both a 24-volt version for use with the PLC and programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. And that concludes our look at the first 9 variations of simulation models. The next simulation model is designed specifically for demonstrating and teaching about cloud-based monitoring and control. This is the Training Factory Industry 4.0. This model is designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a large scale. Now, as the following video provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
FischerTechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 FischerTechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the FischerTechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. Production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The FischerTechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Well, I hope you'll agree that that's fairly impressive in presentation. Now, the following topics can be addressed with the FischerTechnik Training Factory Industry 4.0. Again, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, and digital traceability with NFC/RFID technology. Customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, the connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. As you just saw, this model incorporates many features not found in the other models we previously discussed, besides just most notably, the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enables the positions of each workpiece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, the version of the model which we just saw in the video is the 9-volt version, with the control facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously today, these are programmed not using RoboPro again, but using C, C++. Again, all the programming is preloaded so that once connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, you should be able to get started quickly. Dimensions for this model are approximately 39 by 31 by 16 inches, and it has a weight of approximately 53 pounds. The 9-volt version will require the addition of 3 120-volt power adapters, the ability to access the internet, and is, of course, a tablet or a device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models we discussed previously, we recommend the travel case to help protect your model during transport or storage. Now, there is, of course, also a 24-volt version of this model that is now available. While the 24-volt version is in many ways similar to what we've just discussed, let me very briefly outline what makes it different. First, it's a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one FischerTechnik Robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the FischerTechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway that uses Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the FischerTechnik cloud, as we just saw in the 9-volt versions video, but also to be able to display data and calibrate stations of the factory in a Node-RED dashboard. Now, this model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. And finally, one of the most important new features. Unlike any of the previous 24-volt models we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. In this case, the program is in structured text format and was created based upon a Siemens S7 1500 PLC, and it's available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. The source codes needed are also available for download, once again from GitHub. All of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website. We, of course, have it posted on the Studico website as well, so you can download it and the other materials from the website. And that is the Training Factory Industry 4.0 model, once again available in both 9-volt and 24-volt variations. Of course, the big question now might well be, how much do these models cost? So with that in mind, let's take a quick review of each option we've gone over, along with pricing for each. First off, the vacuum gripper robot. In this case, the 24-volt version, requiring PLC, is $899 each. The 9-volt version, coming pre-wired to the TXT controller, is $1,199 per unit. The automated high bay warehouse, in the 24-volt version requiring PLC, is $1,035. The 9-volt version, including the TXT controller, is $1,319. The multi-processing station with oven, in the 24-volt version, it's $989, once again requiring PLC and programming. The 9-volt version with the program, with the TXT controllers, is $1,479. The sorting line with color detection, in the 24-volt version, $819. In the 9-volt version, $1,129. The factory simulation, this is the regular non-IoT version. 24-volt version requiring PLC and programming is $3,729. The 9-volt version, pre-wired to the robotics TXT controllers, is $5,239. The conveyor belt, in the 24-volt version requiring PLC, is $220 per unit. The 9-volt version, pre-wired to the TXT controller, is $519 each. The punching machine with conveyor belt, in the 24-volt version, $289 per unit. In the 9-volt version, $599 per unit. The 3D or 3-axis robot, the 24-volt version, is $829 each. The 9-volt version, pre-wired to the TXT controller, is $1,099 per. The indexed line with 2 machining stations in the 24-volt version, $879 each. In the 9-volt version, it is $1,399 per. And for exploring IoT and teaching IoT, the Training Factory Industry 4.0, the 24-volt version, $7,365. Again, this comes with the sample programming. In the 9-volt version, pre-wired to the robotics TXT controllers, it is $6,495 each. And as we've talked about some of these other items as well, the 9-volt models, which require 120-volt power adapters for operation, in this case, they are available at a cost of $12.99 each. So however many I mentioned that you would need, you add an extra $12.99 per, and you will get that. The 24-volt versions, again, as I have mentioned throughout the presentation, will require the end user to have or obtain their own choice of PLC, and again, to provide all programming required, all power supplies, and any other hardware. Once again, and if you wish to purchase one of the aluminum plastic travel cases for either version of the factory simulation, or also for the Training Factory Industry 4.0 models, These cases are available at a cost of $1,000 each. So in this case, if you do have any questions, this would be a good time to go ahead and type them in. There's a chat window that should be available on the Zoom toolbar. There's also a question and answer window. If you have that open already, you can feel free to type in any questions you might have. I won't wait too long. I'm going to move along to the next slide, but if you do have a question, please feel free to type it in. But in the meantime, I'm just going to go over taking the next steps. So if you would like to request a full color brochure and current pricing, if you'd like to ask any questions directly, if you would like to request a quote, speak with your dedicated educational representative for whatever state you're in. If you're a commercial customer, you would probably speak to me. In either case, you could call us at Studica US. Our number toll free is 888-561-7521. If you have general questions, just need a quote, what have you, you can email us at info@studica.com. Just tell us what you're interested in or what you have a question about. We'll be happy to help. If you have a question for me directly, if you'd like me to go over anything that I've talked about today or have not talked about today, clarify anything, provide quotes, what have you, you can also contact me directly. That is my direct email address, lance.zurek, lance.zurek @studica, studica.com. So on that note, I would like to thank you very much for taking the time to attend today. We look forward to hearing from you, and we hope you stay safe, and we speak to you soon. Take care.